Logic, in its purest form, is the study of valid reasoning. It provides a framework for analyzing arguments and determining their validity. Within the vast realm of logic, propositional and predicate logic stand as two fundamental pillars. These systems of logic provide us with powerful tools to represent knowledge, reason about relationships, and draw sound conclusions. Propositional logic, as its name suggests, deals with proposition statements that can be either true or false. It allows us to combine simple propositions using logical connectives like and or, and not to form more complex expressions. Predicate logic, on the other hand, delves deeper into the structure of propositions, allowing us to analyze the relationships between objects and their properties. In this exploration, we will journey into the heart of propositional and predicate logic. We will uncover their key components, understand their strengths and limitations, and witness their profound impact on various fields, particularly in the rapidly evolving world of artificial intelligence. Our journey begins with the foundational principles of propositional logic, where we will unravel the building blocks of this essential system of reasoning. By understanding the basics of propositional logic, we lay the groundwork for comprehending the more intricate concepts of predicate logic and its applications. Propositional logic, also known as sentential logic, forms the bedrock of many logical systems. It provides a formal language to represent and reason about propositions, statements that possess a truth value, meaning they can be either true or false. For instance, the sky is blue is a proposition because it can be either true or false depending on the weather conditions. In propositional logic, we use symbols to represent propositions, making it easier to manipulate and analyze complex statements. These symbols, typically letters like P, Q, or R, act as placeholders for specific propositions. For example, we can represent the proposition "the sky is blue" with the symbol P. The true power of propositional logic lies in its ability to combine and modify propositions using logical connectives. These connectives, such as and or not, if, then, and if and only if, allow us to construct compound propositions from simpler ones. By understanding the rules governing these connectives, we can determine the truth value of compound propositions based on the truth values of their constituent parts. This ability to manipulate and analyze truth values forms the foundation of logical reasoning in propositional logic. To solidify our understanding of propositional logic, let's delve into some concrete examples. Consider the following propositions. P, it is raining. Q, the ground is wet. We can combine these propositions using the logical connective and to form a compound proposition. It is raining and the ground is wet. In propositional logic, we represent and with the symbol. Thus, the compound proposition becomes PQ. The truth value of PQ depends on the truth values of both P and Q. If it is indeed raining, P is true, and the ground is wet, Q is true, then PQ is also true. However, if either P or Q is false, or if both are false, then PQ is false. Similarly, we can use the logical connective, or represented by the symbol, to form the compound proposition "it is raining" or "the ground is wet," denoted as PQ. In this case, PQ is true if either P is true, Q is true, or both are true. PQ is only false if both P and Q are false. These examples highlight how propositional logic enables us to express complex relationships between propositions using a concise and unambiguous language. By understanding the truth tables and rules associated with each connective, we can systematically analyze the truth values of compound propositions. While propositional logic provides a solid foundation for reasoning about truth and falsehood, it has limitations in expressing more nuanced relationships and quantifications. Enter predicate logic, also known as first-order logic, a more expressive system that expands upon the capabilities of propositional logic. Predicate logic introduces the concept of predicates, which are statements about objects or individuals within a specific domain. Unlike propositions, which are simply true or false, predicates assert something about their subject. For example, instead of saying "the sky is blue," we can use "the predicate is blue" and apply it to the object sky. In predicate logic, we represent predicates using uppercase letters, often followed by the objects they describe in parentheses. For instance, the predicate is blue applied to the object sky can be represented as "blue sky." Furthermore, predicate logic introduces quantifiers, symbols that allow us to express quantities and scope within our logical statements. These quantifiers, such as for all and there exists, enable us to make general statements about entire collections of objects.